Hello again, this is Dr. Marion Carroll, and this is lecture number 5, I believe. And we're at South Central Louisiana Technical College in Reserve, Louisiana. And I'm teaching a group of production technology students, general chemistry. And so we're going to be covering the very basics of chemistry. We're up to, I think we're going to be talking primarily about molecular and atomic weights, weight here, molecular formulas, percent, composition, and I'll even throw in a little bit of what a mole is and Avogadro's number. As it refers to a mole. Alright, so this is important to know because in analyzing compounds, to know the ratio of different atoms to one another in a compound, in a molecular formula, it's important to know that because a simple change like the ratio of two hydrogens to one oxygen is very different from two hydrogens to two oxygens. So if we know this is number 1, 2, to be confused with 10 and 20. So the ratio of one oxygen to two hydrogens, okay, you're very familiar with, is H2O. Two hydrogens to two oxygens is H2O2. Two very different compounds, and they are different because of the ratio of the same elements to one another. So in discovering compounds, trying to determine what they are, what they're made of, part of that process is determining what the ratio is of elements like hydrogen and oxygen to one another in order to form a compound or a molecule like water. Okay, and remember, elements, individual elements that are found in the periodic table consist of the same atom. Compounds tend to be more than two atoms, different atoms in combination, and these will be referred to as molecules. Sorry, not compounds. But in a sense, these are compounds, but compounds can consist of more than two elements in a combination, a varying combination. So we're going to look at a few examples of this. So, molecular weight. What is molecular weight? Okay. Molecular weight is simply the sum of the atomic weights. Okay, the atomic weights that we get from the periodic table. So when you sum them up and you get an average mass, you get what's referred to as the molecular weight. And we express the molecular weight in atomic weight units. All right, for example, I used water before. Water, the molecular weight of water, consists of 2 atoms of hydrogen and 1 atom of oxygen. And we all know that the atomic weight of hydrogen is 1. That's the atomic weight. And the atomic weight of oxygen is 16. Now we know we have 2 molecules of hydrogen and 1 molecule of oxygen. So that gives us 2 atomic mass units, U, of hydrogen and 16 atomic mass units of oxygen, for a total of 18 atomic mass units. And that is the molecular weight of water. And we'll look at it later, but you'll find out that, I'm going to give myself a little room here, the (18) atomic mass units is equivalent to 1 mole of water. All right, and what is a mole? Okay, 1 mole is equivalent to 6.02 times 10 to the 23rd atoms, or in this case, molecules, since water is a molecule. And so 6.02 times 10 to the 23rd atoms is equivalent to 1 mole. And so if I have 18 atomic mass units, I have 1 mole of water. And if I want to express that in grams, it is also 18 grams per mole. And that is equal to the molecular weight of water. Okay, this is the simplest way I can put this. Now, we'll look at formula weights and some more gram formula weights and percent composition. I think I'll use part 2 to explain that. But these are the basics of understanding molecular and atomic weight, how the formulas are determined. We use a mole in Avogadro's number, and so we'll talk in part 2 about percent composition, and we'll end with discussion of isotopes to end our lecture 5. Okay, talk to you again.